Hello and welcome. In this video we're going to take a look at how we can add an Angular based user interface into IdentityServer 6. Now by default the Quick Start user interface is written in Razor Pages. However, you are free to use any framework that you like for the interface for IdentityServer. It doesn't need to necessarily be Razor Pages if you don't want it to be. So in this video I'm going to show you essentially how you can implement the user interface for IdentityServer using Angular instead of Razor Pages. So over on the left hand side we have an IdentityServer project and a web application project set up ready to go for this sample. The web application project is simply just a file new ASP.NET Core web application. However, it is set up with authentication. So inside the startup, we have our OpenID Connect configuration to allow it to authenticate using the IdentityServer. And we also have an account controller that contains a sign-in action and a sign-out action that trigger the sign-in flow and sign-out flows respectively. So that's our web application. And then we also have our IdentityServer application. Inside our program startup, we add our ASP.NET Core Identity application DB context. We then add ASP.NET Core Identity itself, along with a claims principal factory for our custom properties, given name and family name. And we also add in our entity framework application DB context. We then add IdentityServer, adding in the ASP.NET Core Identity integration. And we then add the configuration store and the operational store. We then add the necessary middleware to the application. And then at the bottom here, if the environment is development, then we migrate the databases and then make sure that we have the appropriate data seeded into the databases. In this case, a user, a client for the web application, and also identity resources for OpenID, profile, and email. So the first thing that we are going to do within the IdentityServer project is create a controller. That's because the Angular user interface will need a means to communicate with the backend IdentityServer. So what we'll do, back inside that startup, we can say builder.services add controllers, like so. And then inside our middleware at the very bottom, just beneath the middleware, we can say app.map controllers. And now what we can do is we can right-click IdentityServer and we can add a new directory. We will call this directory controllers. And inside here we will add a new controller called account controller. And this will contain the logic for our login and logout endpoints. So this will extend from controller. And inside here we are going to inject a few services. The first one of which will be the IdentityServer interaction service, this one down here, like so. We'll then also inject the IdentityServer server URLs, like so. And then last but not least, we will also inject the ASP.NET Core Identity Sign-in Manager, passing in our custom application user type, like so. And then what we'll do is we will generate a constructor for each of those three properties. Now the first endpoint that we are going to implement is our login endpoint. And so for that we are going to want to first of all create a request model in order to model the request from the Angular front end into the IdentityServer backend. So to do this we will create a new record called a login request model. This will contain a username, a password, a nullable return URL, and finally a Boolean property called isPersistent, which will default to false. IsPersistent will essentially determine whether or not to keep the user signed in between sessions. Now that we've created that request model, we can implement the endpoint itself. In order to do that, we will create a new post endpoint called /API/login. And then we say public async task of type iActionResult login. And then from the body, we will bind that login request model like so. And the first thing we're going to want to do is check to see, is the request model valid? If it's not, then we can return a bad request to the front end, passing in the model state in order to get some details into what was not valid in the request model. If it is valid, then we can perform a bit of validation on the return URL. So the first thing that we are going to want to do is we're going to want to unescape the return URL string itself. So we'll say model.return URL not equal to null. You'll recall it was a nullable string, so we need to check to make sure that it is not null before using it. Then we can say URI.unescape data string model.return URL. Otherwise, simply set the local return URL variable to null. Then what we can do, if the return URL equals null, or if the return URL is not valid, then we can set the return URL to just a default value. In order to check that the return URL is valid, we can use the interaction service. And we can say get authorization context with that return URL. And if the authorization context is null, then we know that the return URL is not valid, and so we can overwrite it with just a default value. In this case, I'm going to set it to serverurls.base URL, which is just the base URL of the identity server, but feel free to use any default value in there that meets your requirements. Next up, we are going to attempt to sign the user in. So we can say var result equals await sign in manager dot password sign in async, and we can say model dot username model dot password, and then model dot is persistent, and then I'm going to set the lockout on failure to false. However, if you want the user to be locked out of their account if they fail to sign in, then you can set that to true depending on your requirements. And what we can then do is we can check the result. So we can say return result succeeded, then return OK. If it didn't succeed, then return bad request. And inside this OK, we're going to return an anonymous object with that return URL, so that the front-end Angular application knows where to redirect to if the sign-in was successful. Now it's important to note that generic bad request there without any sort of additional information or details. That's because we don't want to potentially leak usernames to malicious users. That's because if we returned an error message there stating that the username was correct but the password was incorrect, then we've just given away a genuine, correct username to a potentially malicious user. That is especially pertinent if you use an email address as the username, which many systems often do. You don't want to reveal genuine email addresses to malicious users, especially because email addresses, of course, are personally identifiable information. So it's important and very much, good security practice to just return a generic bad request without any details of what specifically was invalid, to keep it vague and keep it secure. So that is the logout endpoint, and we're now going to implement the first of two logout endpoints. Now the first one is going to be an HTTP GET, and it's going to be /API/logout. And this is going to again be public async task iActionResult, and we call this one logout. And we then bind from query a string of logout ID. And the logout ID essentially allows us to identify the logout context. So what we'll do is we'll say var logout request equals await interaction service dot get logout context async with that logout ID. And what we are then going to want to do is check to see if that logout request is null, or check to see if we need to show a prompt to the user to prompt them whether or not they do actually want to log out. So our first condition in the if statement is if the logout request is null, or if the logout request is not null and they need to show the sign out prompt to the user, then we do that inside this condition. So logout request dot show sign out prompt, and if the user is authenticated, user.identity is authenticated equals true. In other words, if there's no context for that logout ID, or if we need to show the sign out prompt to the user and they are indeed signed in, then we can return an OK response. And inside here we can have an anonymous object, and we can say prompt equals user.identity is authenticated, or default to false if that is null. So essentially, if the user is signed in and either the logout context is null, or indeed they're signed in and we are required to show them the sign out prompt, then return a response back to the front end determining whether or not to show that confirmation prompt before actually signing out the user. Now if the logout request is not null and we do not need to show the sign out prompt to the user, then we can simply go ahead and sign them out. So we can say await sign in manager dot sign out async, and we can then say return an OK response. And inside here we will return a new anonymous object, and we'll say iframe URL equals logout request dot sign out iframe URL. The iframe essentially allows us to perform a front channel sign out for other clients that the user may be signed into in addition to the application they're signing out of, to make sure that we're performing a single sign out, so they sign out from everywhere and not just the one application. It's important that the Angular UI renders this iframe as part of that front end. And then what we can also do is specify the post logout redirect URI. And this is the redirect URI for the Angular application to redirect the user back to after they've signed out. And this is again logout request dot post logout redirect URI. So essentially what this logout endpoint is doing is it's checking to see if the user needs to be prompted to confirm the sign out. If they do, then it will return an appropriate response back to the front end, and if not, it will just go on ahead and sign the user out, returning the iframe URL for the Angular UI to render, and also the post logout redirect URI for the Angular application to redirect the user back to. Now, if the user is prompted to confirm that they do wish to sign out, then they will need to, the Angular user interface will need to post to another logout endpoint to essentially finish off the sign out flow. So this is going to be a post, and so this is http post /API/logout, so the same URL but a post instead of a get, and we then say public async task iaction result, and this will be post logout, again with the logout ID from the query string, like so. And inside here we are going to do exactly the same as above in terms of getting the logout request. So we'll say await interaction service get logout context async with the logout ID. And then what we are going to do is copy the sign out logic from above and simply just go on ahead and sign the user out returning the iframe URL and the post logout redirect URI. Importantly, adding in those couple of question marks there because the logout request is nullable. So that essentially is our account controller with the login endpoint and the two logout endpoints. And again, I've created them using a URLs of /API/login and /API/logout respectively. However, you could change these URLs to be whatever you like. And again, you don't need to use HTTP, for example. If you wanted to, you could use GraphQL, queries, mutations, etc. Doesn't have to be HTTP. That's just what I'm using for the purposes of this sample as a means of communication between the front end and the back end. So now that our account controller is done, we can start work on the Angular application itself. So what we are going to want to do, inside our program startup logic, underneath our map controllers, we're going to want to set up a fallback. So we can say app.map fallback to file, and then we can say index.html. That essentially means if there is a route that is not recognized within the IdentityServer backend, then it will be essentially forwarded on to the index.html file, which is of course the HTML file that's hosting our Angular applications, JavaScript and HTML, etc. So essentially what that means is any routes that are not provided by IdentityServer or by our custom endpoints will fall back to the Angular application and be routed accordingly in the Angular application. So now what we are going to want to do is open up the terminal, and I'm going to cd into the IdentityServer project. And what I'm going to do in here is create a new Angular application. So I'm going to use the Angular CLI to create a new application called IdentityServer, and I'm going to output that application into a folder called Client App. And as you can see there, it's output all of the source files into the Client App directory, and it's now just going to take a few moments to install the npm packages and finish up creating that application. So as you can see, just took a few minutes there to finish up installing the packages, and we can see there that it has successfully created a client app directory. And if we open up the client app directory, we have our Angular application. So what we are going to do now is set up a proxy between the Angular front end and the IdentityServer backend. This will enable local development to be much more seamless because we can run the applications via localhost and use that proxy to proxy requests from the front end to the back end. So what we're going to do, inside the source folder, we're going to create a new JSON file, and this is going to be called proxy.conf.json. And inside here we are going to set up the route/API, and we are going to target that to our backend. That's going to be HTTPS and localhost port 7000, which is the URL for our IdentityServer backend. And we're going to set secure to false because we're just using a self-signed certificate that will skip certificate validation essentially, so that requests can make it through the proxy without any issues. So that will essentially proxy all requests to /API from Angular to HTTPS localhost port 7000 /API/ whatever else comes after the path. Now what we can do inside our angular.json, we can scroll down to our serve configuration, and under our development environment we can set up our proxy configuration file, and that is under source and then proxy.conf.json. That means that when we serve our application in the development environment, it will automatically wire up that proxy for us as part of the application. So that's the proxy configured in the front end. And now we can configure the proxy in the backend. So what we will do is right-click IdentityServer, edit, and we're going to edit that CS_proj file. And we're going to want to add a few bits and pieces in order to set up that single page application and integrate it into the backend. So inside our property group at the top, we're going to set up the spare root to be client app. If you created the app in a different directory, then make sure you set this spare root to wherever you created that Angular application. The server URL, we're just keeping as the default localhost port 4200. That is the default port for an Angular application. Again, if you're using a different port, then make sure you update that server URL accordingly. And then last but not least, we have the proxy launch command, and that's the command that will be run to launch the Angular application alongside the ASP.NET Core Identity Server backend. You will notice if we open up the package.json, we have this start script here, which corresponds with npm start as the launch command. So what we are then going to do is add an item group for the client app. So underneath the existing item group with all of our dependencies, we're going to create another item group for our client app directory. So you can see here, don't publish the single page application source files, but do show them in the project files list over on the left hand side. And we can see there it's excluding the node modules, so we won't see that node modules folder in the solution explorer. Next up, we are going to want a couple of targets, specifically for building the single page application when we publish the ASP.NET Core Identity Server application. So these couple of targets here, essentially the first one here will ensure that we have a node environment set up and working. So you can see here it's going to check to see that node version returns successfully, and it's then going to run an npm install inside the client app folder. You'll notice these spare roots dotted around are essentially references to the spare roots up here in the property group, which is that client app directory. And then next up, the second target is to actually build and publish the single page application as part of the process of building and publishing the identity server itself. So when we publish the identity server application, it will perform an npm install and then perform an npm run build, which will essentially build the Angular application. And you can see here it's then going to take all of the files from the dist identity server folder inside the client app directory, and it's going to copy those into the www root folder, which as it stands just creates a placeholder, just has an placeholder favicon icon in there. So essentially that publish run webpack target will basically take the built Angular application and it will copy it into that www root folder, where it's then served by the static files middleware in the identity server startup logic. And we can see that if we open up the program, we have our use static files middleware set up in order to serve those static Angular files. So what we can now do is to actually start work on the user interface for the identity server pages. So what I am going to do is, back in the terminal, is I'm going to cd into the client app directory, and I'm going to generate a module for accounts. So this is going to be an account module, and this module will contain the login component and the logout component. I'll set the usage analytics to yes there. Again, yes or no, depending on your preference. And as we can see, if we open up source and app, we now have an account module and account routing module. So next up, we can generate a component for login. Again, running generate component account /login using the Angular CLI. Give that a few moments and we have a login component. And then we're going to do the same thing for a logout component. Again, in the same account module, that will generate us a logout component. And we can see here we now have a component for login and a component for logout. And it's also updated the declarations of the account module for us. Now what we are going to do is update the routing of the Angular application. So inside the app routing module, we are going to set up a lazy loaded route for the account module. So for the path account, we are going to load children. This will be a callback function, and this will be import and account /account module, then return the account module. So essentially, when the user navigates to /account, it will load the account module. And inside our account routing module, we can then define the routes for login and logout. So we can say a path of login should render the component login component. And likewise, we can do the same thing for a path of logout, rendering the logout component, like so. So if the user goes to /account /login, it will render our login component. And if they go to /account /logout, it will render the logout component. So that's the routing for the application set up. And then we can now go back into the IdentityServer configuration in our startup. And we're going to want to update a couple of options in the call to add IdentityServer. So inside here we can say IdentityServer options, and we can then specify IdentityServer options .user interaction login URL. This is going to be /account /login in order to match that route that we just set up in the Angular application. We're then going to specify user interaction login return URL parameter. This is going to be return URL in a camel case to match typical web conventions. And we're then going to want to set up similar for the logout URL /account /logout. And then we're going to do the same thing again with user interaction. And then the logout ID parameter is going to be logout ID in camel case in order, again, to match typical web conventions for query strings. So this will basically wire up the identity server so that it goes off to /account /login in order to show the login UI and goes to /account /logout to show the logout UI. And these routes will be unknown in the backend server side, and so it will trigger the fallback to file of index.html, which will then kick into the Angular application, and the Angular application will then route these URLs accordingly to the appropriate component within the Angular application. So now that that is done, we can come back into our Angular application and we can import a couple of modules. So the first one that we're going to want to import is the HTTP client module from Angular Common HTTP. We'll import that into the app module, and then inside the account module, we are going to import the reactive forms module. So what we can now do inside our login component is we can now get to work implementing the user interface for the login component. Now it's important to note at this point, I am just going to render just vanilla HTML for the user interface. I'm not going to be using any fancy sort of frameworks or anything like Bootstrap or Angular Material, etc. I'm just going to use vanilla HTML to keep it nice and simple. Of course, in your application, you'll probably want to style the UI using either your own styling or a framework, for example, Angular Material. So what I am going to do inside this login component is remove the onInit, as we won't need that. And then what I am going to do inside the constructor is inject, first of all, the form builder. So we're going to say private form builder, and that's going to be of type form builder. And then also we're going to inject the HTTP client, like so. And then last but not least, we are going to inject the current root. So we'll say private root, and that will be of type activated root, like so. And what we are going to do is then we are going to specify a property for a login form. So that's going to be login form equals this dot form builder dot group, and this is going to be where we create our login form. So we're going to create a field for username with a blank default value, and then we're going to use the required validator to make sure that a value is specified for that field. Next up, we're going to do the same thing for password, again with an empty default. However, we'll say validators dot required again to indicate the password is required. And then last but not least, we will have an invisible field for return URL. So this return URL will be within the form builder, within the value, but we won't actually render that as a field in the user interface. So what we'll do for this is use the return URL from the root. You'll recall in the IdentityServer startup, we updated the name of the login return URL parameter to be return URL. So we can use this value here to get that return URL. So what we can do is we can say this .root .snapshot .query param map, and then we can say get and then return URL. If you chose a different name for that parameter, then make sure you use whatever name you registered in the IdentityServer options in the startup to make sure that they both match each other. So what we can now do is we can create a method that will be called when we submit the form. So what we can do is we can simply say on submit, like so. And we can then say this .http.post, and this is going to post off to our login endpoint. So we can say /API/login, which is our post endpoint, and then we can specify a body of this .loginform.value, and essentially that will take these properties, username, password, and return URL, and it will post those off as JSON in the body of this request. Then what we can do is we can subscribe to this like so, and we can then say next. And inside here we can use the return URL that we return back from the login endpoint in order to return the user back to the application that they came from. So we can say inside here window.location.href equals return URL, like so. And what we can then do is add a type into our post, and we can specify a type return URL, and that is a string. And essentially that strongly types our HTTP request so that the body that we get back is automatically deserialized to match that structure. And what we can also do is just perform a bit of error handling. And so we can say if we get an error, for example, a bad request, then we can say this dot login form dot reset. And that will essentially reset the login form back to just the default values if there is an error during that HTTP request. So that is the TypeScript logic created for the login flow. And now if we pop into the HTML, we can get rid of this boilerplate code, and we can implement the user interface for the login form. So we're going to create a form, and we're going to say form group equals login form, like so. and then we'll say ng-submit equals onSubmit. That's our onSubmit method that we just created to handle the submission of the login form. Now what we will do in here is we will start off by creating a field for username. So what we'll do is we will specify an input. We'll set up the autocomplete to be a username, and then we will specify the form control name, again to be a username, because that was the field in the login form group. We'll then give it an ID of a username to match, and then we will set it to required, and then we'll set the type to just be text. And then we'll also create a label for that input called a username, and this is going to be a label for username, like so. Next up, we will do the exact same thing for the password field. So I'll just copy and paste the username for ease. Autocomplete to be a current password. Form control name password. I'll also update the ID to be password and the label to point to that password input. Do that like so, and then I'll change the type here to be password, as this is going to be a password field. And then last but not least, we will create the submit button. So this will be our login button, and this will be a type of submit, so it will submit the form when the user clicks it. And then we will disable the button if the login form is invalid. So the button will only be enabled if the user has completed the form and it's passed all of the validation. So that is the login component implemented, and now we can implement the logout component. So what we will do inside our logout component, again we start off with the TypeScript. We can get rid of the ng on init, as we don't need that. Inside the constructor, we can inject the HTTP client, like so. And we can also inject the root by getting the activated root, like so. And then what we are going to do is get the logout ID by saying this.root.snapshot query param map.get, and this is logout ID. Much like with return URL, this should match the value that we set up in the startup IdentityServer options for the logout ID parameter. Next up, we're going to create an observable for the response that we get back from the logout endpoint. So you'll notice the $, that's a convention there. If a property is observable, it's typical convention to end the variable with a $, to signify that it's an observable. So we'll say response equals this.http, and then we'll say get, and the URL is going to be /API/logout, like so. And then we are going to specify the logout ID parameter. So we'll change those single quotes to backticks, and then we'll say logout ID equals logout ID, like so, this.logout ID. And that will essentially then pass the logout ID into the endpoint in order for it to get the logout context and perform the appropriate logic in the back end. And what I'm going to do is add a type to this GET request, so it's nice and strongly typed for us. And I'm going to say prompt is Boolean, because you recall that we return a response with either prompt, or we return a response with an iframe URL that's a string, and a post logout redirect URI, which is also a string, like so. So that's our strongly typed HTTP request to go and get the logout context, whether or not we need to display a prompt or whether we can just simply display the iframe and return the user back to the application without any prompt being required. Next up, we are going to create a method that will be called when the user clicks the prompt button if they have been prompted to do so. So what we can do is we can create a method called onClick, like so, and this is going to set the response. So it's going to be this.response equals this.http.post. You'll remember this is a post for this second logout endpoint. The first one is a get and the second one is a post. Again, if you've used different endpoints and different methods, then feel free to set these up according to whatever you've set up in the account controller in the IdentityServer backend. So what we'll do is we'll say this.http post and then /API/logout. Specify a body of null because we're not going to pass anything into the body, but we will specify the logout ID, and that will be this.logout ID, like so, again, so that it can get the logout context for the current logout flow. And what we will then do is we'll pipe that, and then we'll map that to update this.response. First of all, though, I'm going to copy the type from the get, add it to the post. However, you will recall in the post endpoint, we don't return a prompt, we just return the iframe URL and the post logout redirect URI. Now that's why we've got this pipe in here, because what we can then do is we can specify a map from rx.js, and inside here we can use this value, and what we can do is we can specify the 3 dots and value to destructure the properties from value into this new object, and then we can specify prompt to be false. So essentially it will take the iframe URL and the post logout redirect URI, and it will also set the prompt to be false. And this means that we can perform a nice sort of if statement in the UI to decide which user interface to display, whether it's a prompt user interface or whether it's a confirmation you've been logged out successfully interface. So what we will do now is go into our logout component, HTML. We can replace this logout works. And what we can do is we can start implementing the HTML for the logout component. So we're going to create an ng container, and we're going to say ng if and response with the asynchronous pipe as response. And what that will do, that will automatically subscribe to response and automatically unsubscribe and clean up the subscription when the component is destroyed. What we can then do is we can say ng container again. However, this time we can say ng if response.prompt, and what we can then say is else template, like so. So if the prompt comes back as true, then it will render what's in this container. If not, it will render whatever's in the template that we will create in just a moment. So what we can do is create an h1, and we can say, would you like to log out? ? And then we can create a button and simply put yes in there. And then inside here, we're going to use the onClick method that we created earlier. And essentially that just prompting the user to say, would you like to log out? Yes, or perhaps no. Again, feel free to reword that and style it according to your preferences. What we will then do is create an ng template for template, like so. And this will be our you're now logged out successfully, the confirmation interface. So what we're doing here is we will create an h1 again, and we will say you are now logged out. And then inside a p tag, we will render a link for the user to return back to the application. So we'll say click here to return to the application, like so. And we will wrap up the here in a link tag, an a tag essentially, like so. And the href for this link will be the response.postlogout redirect URI. And just in case that's null, we will pop an ngIf here just to make sure that we do actually have a redirect URI to redirect the user back to. Last but not least, we will add in the iframe. So the iframe will again have an ngIf to make sure that we have indeed got an iframe URL. And if we do, then the source of the iframe will be that response.iframe URL. So it will render that iframe in order to perform the front channel sign out with any other clients or applications that the user might be signed into for that single sign out flow. So that essentially is the logout component up and running for us. So we have our login and our logout. And of course, it's important to note at this point that we have just implemented a login component and a logout component. In IdentityServer, there are pages for things like granting consent, things like the device code flow that we haven't implemented in the Angular application in this sample. I'm keeping it nice and simple and straightforward by just implementing the core login and logout flows, because that's what the majority of applications will need to support at the bare minimum. However, if your application also supports things like a user consent and the device code flow, for example, then you'll need to add in the appropriate UI into the Angular application and add in appropriate API endpoints into the backend IdentityServer application. So what we can now do with the client app created, we can now use our Docker Compose file to run our applications. So if I open up the Docker Compose file, you can see we have a service for the database, we have a service for IdentityServer, and we have a service for the web application. And we also have a volume for the database so that we persist data between Docker Compose sessions so that we don't recreate the database from scratch every single time. So what I am going to do is use that Docker Compose run configuration up here, and I'm going to run that application, which will take a few minutes now to build the web application, build the identity server, and spin up the database. Now this will take a few minutes because as part of building the identity server, it will also build the Angular application and publish it to the www root folder. So this will take a couple of minutes, especially the first time when it's pulling down the Docker images. It will take a little bit longer. So what we'll do, we'll wait for this to build the application, and then we will pick up once everything is built and we'll preview the application in the browser. So as you can see there, we have our applications up and running courtesy of our Docker Compose. You can see we have our database, you can see we have our web application, and we also have our identity server. So what we are going to do now in our web browser is we are going to go to https:// a web application running on port 7002 as per our Docker Compose file. And you can see we have our web application. You'll notice up here in the top right we have a link to sign in. And so if we click on that sign in link, this will now load our identity server. So what this is doing behind the scenes is it's sending a request to IdentityServer, an authorize request /connect/authorize. IdentityServer is then triggering the Angular UI in order to display the login page, which you can see here. We have the boilerplate Angular UI, and then down here at the bottom we have our login form. So what I'll do is I will enter the username thomas.clark, which is the username that I used to seed the identity database. And the password, I simply used a placeholder password of PA55W0RD ! With a capital P at the beginning to satisfy ASP.NET Identity's password complexity. And if we then hit the login button, the Angular UI will then interact with the IdentityServer API endpoints that we created to sign the user in. If that comes back successfully, then the Angular application will then redirect the user back to our web application. And as you can see there in the top right, the link has changed from sign in to sign out. So now if we click on the sign out link, you can see here that we are now taken back to IdentityServer and you are now logged out. Click here to return to the application. And we can see there that the iframe has been rendered for us in order to trigger any potential single site outs to other clients. So if we then click here to return to the application, you can see that we're taken back to the web application and we are prompted to sign in rather than sign out. So essentially that has shown you how you can implement the login and logout pages in Angular as opposed to Razor pages. Now in this sample we've only covered the login and logout flows, and of course there are plenty of other journeys like user consent, the device code flow, etc. that if your application or any of your clients make use of those, then you will need to implement those both in the Angular application for the user interface and in the IdentityServer backend for the API endpoints to perform the appropriate logic. So I hope that's helped you in terms of showing how you can create the user interface using a single page application framework, in this case Angular, and how IdentityServer doesn't just couple you to having to use Razor pages if you would prefer to use an alternative framework for the user interface. So as I say, thank you very much for watching, and I'll see you next time.